Okay, welcome to lesson 13 on formulas. So, lesson 12, we actually did kind of see formulas already. We saw some expressions with variables and we plugged in numbers for those variables. This section on formulas will be a little bit different. We're not going to plug numbers in for variables. We're going to start with a formula and we're going to also end with a formula. So the directions will be a little bit different. So here's what we're going to do. Given a formula, we will solve for a variable. That doesn't mean we're plugging numbers in. We're going to rearrange the formula and get that variable by itself isolated on one side of the equal sign. And again, the answer will just be a new formula rearranged. So this might look a little strange at first, and we'll see some examples with numbers just to kind of show you how similar this is to solving a regular equation, but it will feel a little bit different because of all the letters. And it will feel a little bit strange to not have a number as your final answer. So here's our first example. Number 1, solve for W. The equation is A equals LW. There's no numbers. So to solve for W, notice what we're doing on both sides. We're dividing by L on both sides. Now, why would we do that? Let's go back to the original problem. A equals LW. If we're solving for W, we're trying to get that variable by itself. So what we really want is just W. If there's an L next to it, that means the L is being multiplied by W, L times W. So to get rid of the L, we need to do the opposite of multiplication. We need to divide. So that's why on both sides, we are dividing by L. L divided by L is 1. Anything divided by itself is 1. That's why we're allowed to cancel like this. Okay, that's just equal to 1. We don't even need to know what L is for that to be true. Anything divided by itself is 1. So that cancels out, and then we're left with just W all by itself, which was the goal. Because we divided both sides by L, on the other side, we have A over L. So our original formula was A equals LW. The final formula is A over L equals W. Those two formulas are essentially saying the same thing. So here's another way to see what's happening. Let's replace the variables with numbers just temporarily. So let's say you had an equation that was maybe instead of A, maybe it would be, let's say 10 equals 5W. 10 equals 5W. What would you do to solve for W? Wouldn't you divide both sides by 5? Yeah. So maybe we would do this. We would write it over 5 on both sides. So if you had an equation of 10 equals 5W, if you were to solve for W, you would divide both sides by 5. You'd cross out the 5s because 5 divided by 5 is 1. The difference here is you would actually divide by 5 on the other side, right? You'd do 10 divided by 5 and you would get an answer of 2. So you might write 2 equals W for your final answer. Then let's see, what would you do next? Maybe check your answer by plugging it back in. Okay, so 10 equals 5 times 2, and 10 equals 10, and that all works out. We're not going to be checking our answers in the same way here when we're dealing with variables. The point I wanted to make here is if you had something like 10 equals 5W, you would divide both sides by 5. We didn't have 5, we had L. So if 10 equals LW, then you would divide both sides by L. What if it wasn't 10? What if it was A? A equals LW. We're dividing both sides by L. Okay, so try to think of these problems as similar to equations that you have solved before, where you're adding on both sides or subtracting on both sides, dividing or multiplying. You're still doing those same operations on both sides of the equal sign. It's just that instead of doing something like dividing by 5, maybe you're dividing by L instead. All right. So this first example is actually a formula for area of a rectangle, right? So area equals length times width. So if you know the length and the width, you can multiply them together to find the area. But what if you know the area and the length and you wanted to go backwards and find the width? Wouldn't you divide, right? So if you had a rectangle where maybe the width was 2 and the length was 5, right? Area equals 2 times 5, which would be 10. That's fine. But what if you didn't know that, right? What if you knew that the area was 10 and you knew that, let's say you knew that the length was 5, but maybe you didn't know the W. So maybe you just knew the area was 10, length was 5, and then W was unknown. You could do 10 divided by 5 to find the W. So that's kind of what this answer is saying. Area divided by length equals W. Let's move on and see some other examples so we don't get too caught up in this one formula. All right, like everything, the more you do it, the more sense it will make and the easier it will become. So let's move on to number 2, which is actually very similar. Number 2 says solve for n. The equation is b equals zn. Zn really means z times n. So if we're solving for n, we're getting the n by itself. Maybe we even want to circle it just to kind of remind ourselves. That's what we're isolating by itself. So I want that n to be all alone when this is done. So what we need to cancel out here is the z. So we will divide both sides of the equation by z. Okay, so the original equation was b equals zn. We're solving for n, which means we need to cancel out the z. Z divided by z is just 1. Meanwhile, on the left side, when we divide by z, our answer can be written just like a fraction, b over z. So it's pretty short sometimes for these because there's no numbers to simplify. You're just kind of getting a variable by itself. Whatever operation you do on one side, make sure you do the same operation on the other side. So once again, number 2, the equation was b equals zn. The directions were to solve for n. And we did that by dividing both sides by z. So our answer was b over z equals n. Okay, and I hope that you're noticing that we really need to read the directions to know what to do because we need to know which variable we're solving for. Are we solving for z? Are we solving for b? Or are we solving for n? Each of those would have a different result. In this case, we solved for n. All right, let's move on and take a look at number 3. This one says solve for b. This is a lowercase b. And our formula is a equals 1/2 bh. In case you're wondering, this is the formula for area of a triangle, but that doesn't really matter for our problem here. So if we're solving for b, then the things we need to cancel out are the 1/2 as well as the h. So again, the formula is a equals 1/2 bh. B stands for base in this case. All right, and there's a little note written for us here. Clear the fraction first. If you have a fraction in your formula, work on that first. So, just like the previous examples, the only operation happening here is multiplication. There's no plus or minus signs happening. So it's a equals 1/2 bh. That means 1/2 times b times h. So to clear the 1/2, to clear the fraction, you could think of it as dividing both sides by 1/2. But remember, when you divide by a fraction, what we really need to do is multiply by the reciprocal. So I'm going to multiply both sides by 2 over 1, or just 2 actually, because 2 times 1/2 is really just 1. That cancels out. No more 2 in the denominator, right? So again, if your fraction is 1/2 or 1 over 2, you can just multiply both sides by 2. So what I have left now, because I'm multiplying both sides by 2, I now have 2a equals, now I've written a 1 here. You don't really need that actually, but I'll leave it there for now. 2a equals 1 bh. Okay, I'm solving for b. And really the next thing I need to get rid of is the h. So let's divide both sides by h. Okay, so I've just written that little fraction bar on both sides and put everything over h. The h's will cancel out. 1b, that's just equal to b, same thing. Okay, so my final answer, I have 2a over h on the left side equals b on the right side. And we did it, we solved for b. Okay, so again, just to kind of repeat what just happened, we had to solve for b. Our original formula was a equals 1/2 bh. The first thing we did was clear the fraction by multiplying both sides by the denominator, which in this case was 2. So the 2 canceled out with the 1/2. No more fraction. So we multiplied both sides by 2. Then we had 2a equals 1bh, or just 2a equals bh. Because we were solving for b, we had to get rid of the h, so we divided both sides by h. And that left us with our final answer, 2a over h is equal to b. All right, that was number 3. Let's look at number 4. Solve for w. Okay, and the formula is q equals, then we have a fraction, and the numerator is w minus v over, and then the denominator is f. And again, our directions are to solve for w. All right, well, our w is kind of stuck in a fraction here. Again, just like we cleared the fraction in the previous problem by multiplying both sides by the denominator of 2, this time the denominator of our fraction is f. So let's multiply by the denominator f. So we're going to multiply both sides by f. Putting parentheses around each side, we'll multiply by f. F divided by f is just 1. So look at that, the denominator cancels out. Last time it was the 2's that canceled, this time it's f that cancels. So here's what we have left. Because we multiplied both sides by f, now I have f times q equals, and now on the right side there's no more fraction because the f's already canceled out, so I just have w minus v. Okay, remember our goal here based on our directions is to solve for w. I didn't really do anything yet to solve for w other than I cleared the fraction, so that helped. Now let's look at where the w is. We have w minus v. We've been doing a lot of multiplying and dividing so far, but look at this. We have minus v. So to cancel out minus v, what we need to do is actually plus v. So I'm going to add v on both sides. So again, it's f times q equals w minus v. I'm trying to solve for w. So I'm canceling out the minus v, and I'm doing that by adding v to both sides. Just like if it was minus 3, let's say, wouldn't you add 3 to cancel it out? It's the same thing. So I will add v on both sides. I've just crossed out the minus v and plus v on the right side because those cancel out and add up to 0. And we're about ready to write our final answer because we now have w by itself on the right side. So we've solved for w, we did it, we isolated the variable. Now all we need to do is just copy down what's on the left side. So there's f times q plus v. You can't combine those anymore. Those are not like terms, so don't try to put them together in any other way other than just writing them next to each other with a plus sign. So f times q plus v equals w. All right, so we started off with one formula where q was isolated by itself. And essentially what we did is rearrange the formula, so now w is by itself. And the directions would be different if it had said solve for v or solve for f. Then we would be going about this doing different steps and ending up with a different variable isolated by itself. So it all depends on the directions which variable you're isolating or solving for. All right. That was number 4. Next is number 5, solve for x. This equation is ax plus by equals c. Now before we solve this one's also going to be a couple steps. I am going to write kind of a similar example with numbers. I did that before for one of our earlier problems. I will do it again here. So before we jump into this one, let me just rewrite this problem and replace everything with numbers rather than variables. So let's say you had 2x plus 9 equals 12. What would you do here to solve for x? If you had 2x plus 9 equals 12. Well, wouldn't you subtract 9 on both sides first? 2x equals, and then 12 minus 9 is 3. Okay, if you have 2x equals 3 and you're solving for x, the last step would be to divide by 2. And then you'd end up with x equals 3 over 2. So let's use that equation as kind of a model or a guide for what to do in our equation, because ours doesn't have numbers in it, it's just variables. So ax plus by equals c. We're solving for x. So eventually we will need to divide by a, but not yet. Just like in our previous little example here where we divided by 2 on both sides, what we're going to be doing is dividing by a on both sides, but not yet. That wasn't the first step, right? The first thing we did in our little model equation, 2x plus 9 equals 12, we subtracted 9 on both sides. So instead of 9, we have this by. We can treat that as all one term. Let's start by subtracting by on both sides. Just like how we subtracted 9 in our other example, let's subtract by. We don't know b or y. We don't know what numbers those are, and that's okay. We can still treat this as one term. Because it's being added, we can now subtract on both sides. Okay, so I subtracted by on both sides. Positive by minus by. Those cancel out to 0. So here's what we have left. We have ax equals, and then on the right side, we have c minus by. So this is where it gets a little maybe uncomfortable, I guess, because you're not simplifying as much as we're used to, right? So before we were able to do 12 minus 9 is 3 and just write 3. Well, what if we wrote 12 minus 9 and just left it like that? That's kind of like what we're doing here. Okay, so it's as if we just left it as 12 minus 9. We're writing it as c minus by. So we have ax equals c minus by. We're solving for x. So now we're at the last step where we get to divide both sides by a. In our previous example, we divided both sides by 2, but now we're dividing by a because that's the coefficient. That's the number in front of the x. A divided by a cancels out to 1. Notice how on the right side, I've put the entire expression c minus by all over a, kind of like making it one big fraction. Okay, so we're ready for our final answer now. X equals, we're pretty much just copying down what we just wrote. C minus by is in the numerator of a fraction, and then the denominator is a. So C minus by all over a. That's it. So again, here's what we just did for number 5 to solve for x. We had ax plus by equals c. We subtracted by on both sides. Then we divided by a on both sides. And we ended up with x equals c minus by all over a. All right, number 6 is coming up next. F equals 7/4 parentheses n minus 40 close parentheses. So there's a couple ways to do this one. The first way I will show you is to multiply both sides by the reciprocal of this fraction, 7/4. I'm choosing to do it this way because I noticed that's how the example is shown in your homework. But there's another way. So if you're wondering about distributing the 7/4, I'll show that as a second option. Okay, so I'll show this one in two different ways. So here's number 6, solve for n. F equals 7/4 parentheses n minus 40. So let's start by multiplying by the reciprocal of this fraction. So reciprocal is when you're essentially flipping the fraction. 7/4, we can flip it and write 4/7. So let's multiply both sides of the equation by 4/7. Now, why would we do that? Well, 4/7 times 7/4, that's just 1, okay, because the 4's cancel and the 7's cancel. So we're essentially just left with 1 in front of our parentheses on that right side. So I now have 1 parentheses n minus 40 on the right side, and then on the left side, we can now write 4/7 f. Okay. Now I still wrote a 1 before the parentheses, but the thing is now when I distribute the 1, the parentheses pretty much disappear. So we can also write 4/7 f equals n minus 40. Now remember what we're solving for. Our direction said to solve for n. We're almost done with that. We have n minus 40, so to cancel out the minus 40, the last step will be to add 40 on both sides. So I'll write plus 40 on the right side and the left side. All right, and now we have n by itself. On the right side, and then on the left side, we have 4/7 f plus 40. Okay, so what did we do for that one? We multiplied by the reciprocal of the fraction. So again, our original problem was f equals 7/4 parentheses n minus 40. We multiplied by 4/7 to cancel out the 7/4. That became 1. Then we distributed the 1. 1 times n is just n, 1 times 40 is 40. So we had 4/7 f equals n minus 40, and then to get the n by itself, we added 40 to both sides. So we ended up with 4/7 f plus 40 equals n. Okay, I'm going to show you an alternative way of doing this, because you might not necessarily think of multiplying by the reciprocal as the first step, and that's okay. So I'll rewrite the problem. Here's number 6 again. So it's f equals 7/4 parentheses n minus 40. When I saw this problem first, what I thought of is distributing the fraction. And as it turns out, this is a valid way of doing it as well. So I wanted to show this as an option. All right, so f equals 7/4 times n is just 7/4 n minus 7/4 times 40. Let's do that off to the side here. You can really write it as 40 over 1. And then the 40 and the 4 cancel out. We can reduce those by dividing by 4. 40 divided by 4 is 10. So it really becomes, instead of 7/4 times 40, it's now 7 over 1 times 10 over 1, which is 70. So here's where we are. It's f equals 7/4 n minus 70. No more parentheses now. Okay, now if we want to get n by itself, we should add 70 to both sides. So that's f plus 70 equals 7/4 n. All right, now to get the n by itself, we need to get rid of this 7/4. There's a couple of ways to do this. Here's when we could multiply by the reciprocal if we wanted to. But another option is we can just clear this fraction. We could have done it earlier, but we can do it now. We can just multiply by the denominator. Let's multiply both sides by 4 because the denominator is 4. Okay, so I now have 7/4 n times 4 on the right side. The 4's cancel out, so that'll just be 7n. On the left side, I've put the whole left side in parentheses, so I have 4 parentheses f plus 70. Let's distribute that 4. So now it's 4f plus 280. And last step, to get that n by itself, now I can divide both sides by 7. Okay, now I'm putting the entire expression over 7. So here's one way to write the answer. As one big fraction, 4f plus 280 all over 7 equals n. That's one way to write the answer. Now that does not quite match what we got before. So here's a way to rewrite it. See how the entire numerator is over 7? You could actually split up the terms like this, so it could become 4f over 7 plus 280 over 7. And that 280 over 7 becomes 40. Okay, so remember our final answer that we got before, it was 4/7 f plus 40 is really what we got. So a couple different ways of writing the answer and a couple different ways of solving this problem. If you view the example on the homework for this one, it will have you multiply by the reciprocal, but I wanted to show you that distributing is another option, and maybe you can decide which way seems simpler. I'm not really sure. Probably the reciprocal way is a little shorter, but this is another way as well. Okay, so that's the end of the examples I have in the PowerPoint, but this is a pretty difficult topic for most students, and we could probably stand to do some more examples. So one option for doing this is we could take a look at the MyLabs Plus homework. I think I want to take a moment now to remind you of another place you can go for extra practice. I've shown you this before, but I'm going to take us over to the classwork packets in Blackboard and just remind you that those are available for extra practice as well. So in just a moment, we'll switch over and take a look at those. All right, so here we are in Blackboard, and I wanted to remind you of some extra practice that's available to you. So I would normally hand these out during class, and you'd have a lot of extra paper and packets to work on, just optional extra practice. So if you'd like to print these or just kind of view them on your computer, they're there for you for extra practice if you want. So right now we're in the second unit, so this is for lessons 9 through 14. So if I click here, the lesson we were just working on is lesson 13 on formulas. And so lessons 12 and 13, since they're covered in the same class period normally, I put them together and they're in the classwork practice. So let's take a look at that. Okay, so this is classwork for homeworks 12 and 13. Okay, so the first page here, these are all problems from lesson 12. But what we've been working on just now is lesson 13. So right about here on problem 17 in the classwork where it says solve for the given letter, this is where the formulas begin. So if you want extra practice for lesson 13, here's some practice problems that you can do. Okay, starting with number 17. And it goes all the way through problem 33. And then here's your answer key at the end. Okay, so there's just a couple of challenging problems in here that I wanted to do with you. Partly so I could show you that there's more than one way to write your final answer. All right, let's see. The one that's catching my eye here is this one with the pi symbol. And then I also wanted to do another one involving a fraction. So let's actually look at number 21 in the classwork. This is actually a formula for converting for temperature between Fahrenheit and Celsius. This is number 21. F equals 9/5 C plus 32, and we're solving for C. Okay, so to get the C by itself, we would need to subtract 32 on both sides, and then eventually we'll need to deal with that fraction. Let's subtract 32 first. So now we have F minus 32 equals 9/5 C. Okay, to solve for C now, here we are where we can maybe multiply by a reciprocal if we want to. That would get the problem done in one step. So the reciprocal of 9/5 is 5/9. This is one option. We can multiply both sides by 5/9. Okay, and this right here is technically, if you look it up, the formula for converting from Fahrenheit to Celsius is right here. So it's 5/9 parentheses F minus 32, close parentheses, equals C. So it's often just left like that with parentheses. However, I think we're kind of used to distributing and not leaving parentheses. So you could continue and distribute. That would be fine. 5/9 F minus, and then if you do 5/9 times 32, just put the 32 over 1, and we would just multiply across. So 5 times 32 would be 160 in the numerator, and then 9 times 1 would be 9. Oops. So here's another way to write the answer, 5/9 F minus 160 over 9. You could even combine those as like terms and write 5F minus 160 all over 9 equals C. So those are several different ways of writing your final answer for that one. But the point is you can subtract 32 on both sides, and then to get rid of the 9/5, you can multiply both sides by 5/9. Here's one more way to do that one. I just cleared our work. So if we subtract 32 on both sides, F minus 32 equals 9/5 C. You could clear the fraction at any point. So another option is we could just multiply everything by 5. That's the common denominator here. So then you'd get 5F minus 160 equals 9C. And then you could divide everything by 9. So here, there's yet another way to write your final answer. The answer key will only show one of those, but I wanted to show you some other options. Okay, the next one I want to look at here is number 23. It involves pi. You do not need to know what this formula is for. I believe it's some kind of a surface, maybe surface area of a cone or a cylinder, something like that. Doesn't matter for our purposes. We're just using it to practice with formulas. So here's number 23 on the classwork. So it's S equals 2 pi RH plus 2 pi R squared. And we're solving for H. Okay, first of all, pi, just think of pi as a variable here. You might be remembering that pi is approximately 3.14. Do not replace pi with a number for these formulas. Just leave it alone, pretend like it's a variable, which, I mean, it's a Greek letter. Just think of it like a letter P. Okay, so if we're solving for H, let's figure out where the H is. So we have S equals 2 pi RH, and actually what we should be doing on both sides, sorry, I'm going to erase my work here. I started writing too soon. S equals 2 pi RH plus 2 pi R squared. Okay, so to get that H by itself, let's leave that term where it is. Let's subtract the other term. So the last term that's written here is the plus 2 pi R squared. Let's subtract 2 pi R squared on both sides. Those cancel out. So now we have S minus 2 pi R squared equals 2 pi RH. All right, if we're solving for H, leave the H where it is. We can actually divide by everything else that's next to the H here. So not only do we need to divide by 2, we can also divide by pi and R all at once. So we can actually divide both sides by 2 pi R. 2 pi R. So we've gotten H by itself. So one way to write the final answer is one big fraction. In the numerator, S minus 2 pi R squared over, and then in the denominator, 2 pi R. All right. Good, let's see. So plenty of other examples. Again, the answer key is at the end, but obviously there's no view example, so you might find these a little more challenging, but just some extra practice for you. All right. Let's see here. Let's do one more example. How about number 32? Okay, this is a good one where we're solving for a variable that's actually in a denominator. So here's number 32. P equals A over 1 plus RT. So the 1 plus RT is in the denominator, and we're solving for R. Okay, we're going to start by multiplying both sides by this denominator. Now we've seen this before when there's a denominator of F or 2 or something, but we can do it here when the denominator is 1 plus RT. I'm writing it in parentheses, and I'm just going to multiply both sides by 1 plus RT. So here's what we have left. On the left side, we have P and then parentheses 1 plus RT. We're going to have to distribute that in a minute. Equals A. All that's left on that right side is just A. So I know it doesn't feel like we've solved for R. We haven't, but what we've done is gotten it out of the denominator, and that will make the rest of the problem easier. Okay, so now that we have P parentheses 1 plus RT, let's distribute the P. So P times 1 is just P, plus P times RT, we can write PRT. All right, so P plus PRT equals A. Now is a good time to remember what we're solving for. We're solving for R. So notice where the R is. We're about 2 steps away now. Let's subtract P on both sides next. Get rid of that other term that the R is not part of. What we still have left is PRT equals A minus P. Just rewrite that over here. PRT equals A minus P. We're solving for R, so let's divide by everything that's being multiplied with the R. So PRT, we can actually divide both sides by PT. The P cancels out and the T cancels out, all in one step. So our final answer is R equals A minus P in the numerator over PT in the denominator. Okay. Good. So this is a topic where there's a lot of different variation. Each problem is different, but you're solving for a particular variable. Whatever operation you do on one side, you do to the other side. Okay, I'm going to pause us one more time and just take a quick look at the MyLabs Plus homework, which is what you'll have to do. This is optional extra practice here. I'll take us to the homework momentarily, and then we'll be done soon. Okay, here we are in homework 13. I've actually started number 1. The original equation was all lowercase. It was A equals HQ, solve for H. So what we would do is divide both sides by Q. Now look at what I've written for my answer. My answer should be H equals A over Q. But look, I've typed it in as capital letters. This is not accepted as a correct answer. So the note I'm getting here is be sure not to change the case of any variable in the expression. So in geometry and other topics as well, there's sometimes a difference between a lowercase letter and an uppercase letter. So for example, a lowercase b is the length of a base of a triangle, but the uppercase B is the area of the base of a pyramid or something. So anyway, capitals and lowercases will make a difference. So I just wanted to let you know, because here you go. See, I got it wrong. The correct answer was little a over little q, and I wrote big A over big Q. So just be careful there. So I'll just do a similar question. So C equals HN, solve for H. I'll divide both sides by N. So C over N equals H. So all I need to do is type in C over N in my answer spot, because I already have the H equals given. So H equals C over N, and I've done it in lowercase this time. Okay, good. Oh, and now number 2 is similar. Okay, I'm going to kind of breeze through and see if there's any equations in here that are different enough from what we've done in our notes. A lot of the notes problems are modeled directly after these problems. Okay, here's one. Number 7, K equals NPV, solve for V. Okay, so NP, those are 2 different variables, but if you multiply them together, they would just be one number. So if you picture it as, let's say it was K equals 3V, you would just divide both sides by 3. Instead of 3, it's NP. So we can divide by NP on both sides. So my answer would be K over NP. So just divide by both of them at the same time. So again, the NP's cancel out, V is by itself, and then you're left with K over NP. So V equals K over NP, and I'm leaving them all lowercase. That was number 7. Okay, number 8, A equals HR squared. And we're solving for R squared. That might seem strange. Don't let the squared part throw you off. You're basically being told to treat R squared like it's its own variable. It's not the same thing as solving for R. We don't have the capability of that right now in this class. You'd have to take the square root of both sides, which we're not doing. So here's what we do for this one. A equals HR squared. R squared is the thing you're solving for. So all you need to do is divide both sides by H. And we're done. So R squared equals A over H. Number 9 is a fraction. We would start by multiplying both sides by the denominator. We saw that in our notes as well. Okay. Oh, here's a multiple choice one. This is number 11. Solve the formula K equals 3.75 M over N and solve it for N. Okay. N is in the denominator, so I would want to multiply both sides by N, which seems strange if you're solving for N, but we need to get it out of the denominator. So then I'd have NK equals 3.75 M. Okay, so again, we had M over N on the right side. We needed to get that N out of the denominator. So I multiplied both sides by N. Since we're solving for N, now let's get it by itself. So since we have NK on that left side, let's divide both sides by K. So my final answer should be N equals 3.75 M all over K. All right, the answer will look just slightly different. Okay, so instead of the 3.75 being left in the fraction, we can actually move it off to the side. So 3.75 times M over K, that is the same thing. Okay, so in my problem, this is a multiple choice question, and I can choose that choice D. Okay, but none of the other solutions are even close to what we have. I guess the first one, they just mixed up K and M. Okay. All right, number 12, this is similar to something we did in our notes, where we multiplied both sides by the reciprocal. Okay. Oh, and I see a little fill in the blank here. All right, let's do this one. So it's A equals 7/5 parentheses H minus 78. Let's solve for H. Let's start by multiplying both sides by the reciprocal of that 7/5, which means we're multiplying both sides by 5/7. Okay, the 5/7 times 7/5 is equal to 1, so I'm just canceling them out. All we're left with is just H minus 78 on the right side. Meanwhile, on the left side is 5/7 A. Notice our fill in the blank setup for our solution. The solution is H equals blank A plus blank. So it's going to be 5/7 A plus something. And here's what it's going to be. I have to add 78 to both sides. So 5/7 A plus 78 equals H. Okay, so that now tells me what to plug in or what to type for my answers. So H equals, I get to type 5/7 in front of the A and then plus, then I'll type the 78. So it's kind of forcing us to put the answer in a certain format, because there are other ways to write the answer, but we'll just leave it at this. Okay, number 13, here's another one where I would start by multiplying by the reciprocal. This is D equals 1/9 parentheses j plus a minus b, close parentheses. You could distribute the 1/9, but let's just cancel the fraction right away. So here's another one where we can multiply by the reciprocal. The reciprocal of 1/9 is just 9 over 1, or just 9. So I'm multiplying both sides by 9. That's 9d equals, and now we're just left with j plus a minus b. Now we're solving for a. So I need to get rid of the j as well as the b. Let's start by subtracting j on both sides, because that's positive. So 9d minus j equals a minus b. And since I'm solving for a, the last thing we need to cancel out is b. And since it's a minus b, let's add b on both sides. So I'm writing plus b. So I have, for my final answer, 9d minus j plus b equals a. And none of those are like terms, so we leave them separate. So for our solution, we would type a equals 9d minus j plus b. Okay. Number 14 looks similar to something we've done. 15 looks similar. And 16, oh, I think that's a repeat problem from earlier. Okay, good. So I will wrap it up here. Please ask questions if you have them. This is always a challenging section for students, dealing with formulas, solving for a variable, but having variables in your final answer. So if you're feeling a little bit confused, that's kind of normal at this point. Just keep practicing, and please ask for help as you need to. Take advantage of the Ask My Instructor on your questions, and bring your questions to our class meetings, of course. All right, thank you very much. I'll see everybody soon, and the remaining lesson we have in this unit is lesson 14. So we're almost done with our second unit. We have lesson 14 to go, and then we'll do our second test, which will cover lessons 9 through 14. All right, that's it for now. Thank you.